Good morning, sixth graders. Good morning, good morning. Welcome to the lesson 5 of the class of science. Okay? Today I'm going to make a short video because I want to give you time to finish your classwork. I'm really worried because you didn't advance. Some of you, right? Some of you didn't advance on classwork 1, 2, 3, 4, and 5. So I'm going to make this video short because I want to give you more time to work. The idea is to watch the video and make the classwork on class the same time, the same 40 minutes, and you can approach the time in advance because you are very slow in presenting. So I need you to focus more in your classes. Okay, the last review class I told you and I spoke with you about this problem. Okay, let's go to the lesson 5. We're going to start today and we're going to see lesson 5. Okay, sticky lesson. Today we are going to learn about La Brea tar pits. Why are La Brea tar pits so important in learning about air history? What is La Brea tar pits? The La Brea tar pits is like a museum in California, United States. It's more than one museum. It's like a zoo. It's like a place about fossils and animals, anatomy, examples. You're going to find everywhere a lot of things about fossils, microfossils, and fossilization to or preserving animals, plants. It's a wonderful, amazing place in the United States. I'm going to give you the video. Next to this video, I'm going to put here the video of YouTube of La Brea Pits, right? La Brea tar pits. Okay, let's go and see what's going on with this. Millions of years ago, before the busy city of Los Angeles exists, the area was covered by the Pacific Ocean, right? Over time, it turned from a sea to land. Oil seeped to the surface through cracks in the ground. Right? It pulled in the low-lying areas, which are known today as the La Brea tar pits. It's a place that is very beautiful. During warm periods, the oil that oozes, you're going to learn this word, you're going to look in the dictionary, from the ground became sticky. The surface of the pool would become covered with leaves, dust, and even water. When animals came to drink, they became trapped. Predators that preyed on trapped animals often became trapped themselves. Okay, stop there. Can you imagine? It's like a hole, right? With leaves, water, and the animals trapped inside, and then they stay there because it was sticky. The sticky asphalt was perfect for fossilizing, right, and preserving the remains of these animals. Today, the La Brea tar pits, which are actually asphalt pits, are not one of the best sites for excavating fossils. More than 3 million fossils have been found there. Wow! More than what? More than 3 million fossils have been found there since the early 19th. Wow! The larger fossils, which came from animals like mammoths, saber-toothed tigers, and short-faced bears, are the fossilization in fossils. Look at this example. This is an example about fossilization, right? More example. What's going on with the fossilization, right? The water, the years, and the time make these animals to be trapped in some places, or in other case, the water, right? Or animals that get inside mountains or caves, right? So today, La Brea tar pits, which are actually asphalt pits, are not one of the, bueno, I already read this, right? So the paleontologists who work in the pits, they think that they can find fossils of plants, insects, and smaller animals. The microfossils help scientists from a complete picture of what life was like in the area around Los Angeles, California, nearly 40,000 years ago. For example, by examining plants' life and even fossilized pollen, they learned that the climate was moister and cooler, but not very different than it is today. This was an important finding because an ice age was taking place at a time. The fossil gave scientists a better idea about the range and types of weather during an ice age. Aha. Okay. I'm reading the paragraph, I'm reading the information and try to think what's going on. So, how do experts know how old the fossils remain are? Hmm. They use a process called radiometric dating. Repeat, radiometric dating is a process. Living things contain the element carbon. A small portion of the carbon of Earth is an unstable isotope called carbon 14. Okay, the carbon 14 is an important test evaluation about to see the years of something. For example, in Honduras, in Comayagua, we have the watch of the church of the Central Park of Comayagua, right? The people said that the London watch of London, right, is the most older, is the older watch in the planet, London. And the second, can you imagine where is? In Comayagua. The second watch, the older of the planet. Oh my God, Honduras has this blessing. Okay, but the scientists made the test of carbon 14 to this watch, pay attention, in que they made the carbon 14 to see the material substances or the material years. Can you imagine which one? Honduras. Honduras won. About the carbon 14, Honduras has the older watch in the planet, but London is not going to accept. London is not going to accept. And if you know, London and Honduras is very different, right? Especially for the government, the economy, the everything, right? The education. So for the reason London has like more prestigious, and they want to know and they want to say that they have the older watch. But it's not true. Honduras has the older watch. About the carbon 14. The carbon 14 you can apply, well, scientists can apply for bones, for plants, for material, right? For everything, right? For the hair. And what is the idea? To see the time of each element. So, the carbon 14, right, is one special test. So, how do the experts know how old the fossil remains are? They use the process called the carbon 14, right? This carbon 14 changes to stable atom, but this change happens very slowly. It takes 5,730 years for half the carbon 14 to become stable. Then it takes the same amount of time for half of the remaining carbon to become stable. So, measuring amount of unstable carbon 14 remaining in the fossils allow scientists to accurately date N. by using carbon dating on the fossils in the tar pits, the place, right? The tar pits, they found that most were between 8,000 and 38,000 years old. This might seem ancient, but keep it in mind that dinosaurs lived about 65 million years ago. This, people, is only one theory of the scientists, right? This is one theory. We have other theory, right, about the Bible. If you know the story about Noé and the ark, right, and the water of the Noé story, right, that said that kill all the animals, but they couldn't survive because they were so big, especially dinosaurs. This is other theory that said that the dinosaurs disappeared in this period, right? A lot of water, a lot of precipitation of water destroyed them. This is one theory of the Bible. But the scientists, right, this is other theory. The scientists said that it's about 65 million years ago. They don't exist anymore. And we have like some examples of some dinosaurs that we can call like ancients. For example, the turtle, the crocodile, the ostrich. These animals can be like the ancients of the dinosaurs. Some people said that. Don't tell me. So, pero ya esos animales desaparecieron. Okay, circle the classwork, right? Circle the letter of the best answer to each question below, right? The letter. Why will a scientist measure the amount of carbon-14 a fossil contains? Option A, to find out whether the fossil is authentic. To find out where the fossil was found. To find out what the fossil is made of. And to find out how old the fossil is. Old. Number 2, by examining the types of plants life found in the tar pits, scientists learned that during the last ice age, the climate in Los Angeles was very different than it is today, exactly the same as it is today, cooler and moister than it is today, and hotter and drier than it is today. So you're going to remember in the last page about this is write your answers on the lines below. Explain how animals became trapped in the La Brea tar pits. Remember, right? Remember the leaves, the water, and the substances of the soil. Why it is helpful for scientists to study a wide variety of fossils, including microfossils. Why is helpful for scientists to study, right? Why? And what are 2 common tools that scientists use when they clean in fossils? The brush can be one, maybe. And the 6 is what sorts of comparison do scientists make when they are trying to identify new fossils? What sorts of comparisons do scientists make? Good question to know about this topic. Okay, so bye bye. See you in the next class. Love you so much and behave. Make your classwork.